Hello everyone, and welcome to today's chem lesson. Today we're going to dive into the topic of ionic bonding, which, as we mentioned last time, is when electrons are transferred from one atom to another. Ionic bonding happens between metals and nonmetals when they bond, so it's an easy way to tell based on looking at your pair of elements that you have an ionic bond that will happen. If you see one metal and one nonmetal, more than likely, almost definitely, it is an ionic bond. Again, the key word with ionic bonding is all about transferring electrons, one atom taking the electrons from another. So when we look at a pair like francium fluoride, where we know from our four corners, the one down here is francium, the one up here is fluorine. We know francium is a metal, we know fluorine is a nonmetal, remembering the placement of the staircase and where these elements are in relation to that staircase. That means when we take a closer look at the two of them, francium with 7 valence electrons, or 7 shells, 1, 2, 3, 4, 5, 6, 7 shells and 1 valence electron, compared to fluorine, which has 2 shells and 7 valence electrons. Fluorine is going to steal this electron away from francium. It will pull on this electron until it disappears, leaving francium with a full outer shell and giving fluorine a full outer shell. It also makes these get charges, right? Lost an electron, positive 1 charge, gained an electron, negative 1 charge. And now these two things are going to be attracted to each other because they have opposite charges. Because of those opposite charges, they will be stuck together like magnets and attracted and bonded in that way. Now the interesting thing is that the combination of francium and fluorine together is going to have a whole new set of properties. It's going to be very different from francium by itself or fluorine by itself. And in general, when we look at ionic substances, when we look at a metal and a nonmetal coming together to bond via transfer of electrons, we end up with a new set of properties for the compound than the set of properties that we had for either element. Right? A really good. These properties are universal across ionic substances. There are obviously more properties for any given substance, but these are the ones that are universal across the board. Right? Looking at pretty much every ionic substance, you will see that it is hard with good conductive heat electricity as a liquid or mixed with water, and has high melting points and boiling points. But this is only a side note for the things that we really want to be looking at today. Really what we want to focus in on is how this bond gets made and the things that happen and the way we draw the bond once it is created. So we're going to go back and take another look at vocab first, and then a closer dive at our ions. As we approach and look at these ionic substances, we're going to talk a lot more about ions. And it's a very common pair of vocab words for us to have anion and cation. Anions are negative, and cations are positive, which gives you a nice little mnemonic to help remember it by. Also, you can think the T in cation makes a little positive, so you can remember that it is positive because of that little T. But if we look back and we talk about francium fluoride, which one of these is the anion and which one of these is the cation? Which one of these gained electrons and which one of these lost electrons? In this situation, remember that fluorine took the electron away from francium. So fluorine ends up with an extra electron, which makes it the anion. Francium lost an electron, which makes it the cation. It is important to remember that gaining electrons makes you negative. You are taking more negative things, so you are becoming more negative. So it doesn't actually change any of the concepts here, right? It's still fluorine takes the electron away, becomes negative, but now we just have another vocab word here that we could use in order to describe or refer back to positive cations or negative anions. This brings up our final point for the day, and that's how do we draw an ionic bond? How do we draw something that has formed an ionic bond? And we're going to bring back the idea of Lewis dot diagrams for this. Remember that for a Lewis dot diagram, you put your symbol in the middle and you surround it with dots to help keep track of how many valence electrons there are. So for something like fluorine with 7 valence electrons, we're going to put 7 dots in the appropriate spots to show fluorine's 7 valence electrons. And for francium, we are going to put 1 dot to show its valence electron. This is our lovely before picture. Right, using stuff that we learned in the past here. After bonding, though, we're going to have fluorine, which has its 7 valence electrons, but has also taken francium's valence electron. And we're going to have francium without any, because it lost its valence electron that was up here. But this doesn't really look like a picture of two things that have formed a bond. This just looks like a picture of two different elements. We have no way of seeing these linked together right now. And that's because this picture isn't finished yet. When you draw the Lewis structure of an ion, you include brackets around the ion with the charge of that ion outside the brackets to show it's not just fluorine, it is fluorine minus 1. It is a negative ion. The same thing goes for francium. Brackets and a charge. And then to show that they've bonded, what we're actually going to do is draw them right next to each other. And by moving them over and writing them and drawing them next to each other like this, now it appears as though they are bonded, right? They're close together, they're not spread apart. We can see that the charges are equal but opposite. We can see where the attraction is coming from. And this is the case for everything that does ionic bonding. We're going to draw them in this way, with the brackets around our ions and the charges outside those brackets. And as we look at more ionic things, which we're going to do right now, we're going to see that they fit themselves together very nicely. One extra electron from francium completes fluorine's outer shell. When we look at something else, when I wipe this one away and give you one to try on your own, when I say give lithium to sulfide a try, or calcium oxide a try, we're going to see that these fit together pretty nicely. For both of these, you should draw a before. Right? What are the elements going to look like before they bond? And then what are they going to look like after they bond? What are the elements the way we've drawn them this whole time? And then what are the ions going to look like? So I'm going to give about a minute for you to set up your befores. And we'll talk through the befores, and then we'll go to the afters. And while you work, I'm going to rearrange this and make it a little nicer. Let's take a look at these befores. Lithium has one valence electron, and so we're going to set up these dot diagrams with one dot above lithium in this position here for our first two electrons. There's only one, so we're only putting one. Sulfur, on the other hand, has 6 valence electrons, so we're going to put our first 2, 3, 4, 5, and then our number 6. The before for calcium and oxygen, calcium has 2 valence electrons, and so they're both going to hang out up top. Oxygen also has 6 valence electrons, and so it's going to look very similar to what we drew for sulfur. Now, ionic bonding is all about the transfer of electrons. And so what transfers are going to happen here in order to make the lithiums and the sulfur stable and the calcium and the oxygen stable? How are those electrons going to get moved around? Sulfur is going to take lithium's electrons, we're going to end up with sulfur with 8 valence electrons, having taken the 2 that did belong to the lithiums. We're going to put our brackets appropriately. Sulfur gained 2 electrons, so it has a -2 charge. Each lithium lost 1 electron, and so we're going to give them +1 charges to show now that lithium has empty shell and sulfur has full shell. Each one stable, attracted to each other because of these charges that hold them together like magnets. When we look over at calcium and oxygen, we're going to see something similar. Oxygen's 6 valence electrons are now supplemented by the 2 that it gets from calcium. Which gives it a -2 charge. Gaining 2 electrons, taking on 2 more negative things makes it a -2 charge. While calcium is a +2 charge, losing 2 electrons. And so this transfer of electrons, just like Kyle says in the chat here, lithium to sulfur, calcium to oxygen. Ionic bonding is all about the transfer of electrons and the creation of ions. There is no sharing happening here. It is a pure transfer. One gains, one loses. Or one gains and multiple lose. Or multiple gain and multiple lose. But it's about transferring those electrons, moving those electrons from one element to a different element. with that, I'm actually going to transfer us over to our Zoom meeting for questions, comments, concerns, and attendance. And I will see you there.